Okay, so in the past video I went over how to plot these beams. This is the ThreeJS environment. In this video, this one will just be a short one about making an actual basic navigation thing work. So right now we're able to probe a distance like this and have a coverage like that. So this is a screenshot without those beams. So if we assume some kind of coverage, let's see, something like that, because it's not symmetrical. And we also assume like a maximum distance. So I'm not sure we can go a circle or cut it off straight. I think you should do some kind of a circle. It just means approximating. So it's like let me like freehand draw. You'd have coverage like this. Yeah, something like that. Anyway, the point is we would then plot measured cubes in ThreeJS. These would be, they're not cubes, they're planes. It would be like aligned with these grids. Yeah. So yeah, we could just be like, okay, here, this whole area is assumed to be clear. And we will know how big this robot is, because you know it has like a box. Oh no, what's going on? Oh, there we go. Okay. And the other thing to keep in mind is the center point of this robot is somewhere like here as far as the axes of the wheels. And when it turns, whichever direction, that produces like a new shape. So I have to figure out the actual shape of this robot based on that turning. So let's say like it goes all the way out to here, then we should treat the robot as like it's actually this big based on the maximum dimensions, like this one and, well, yeah, this one and this one. So if we were to draw like a circle, that's the reason for this box. That's like a very safe way to assume like you're not going to run into anything. Otherwise, you know, say you have like a corridor like this, the robot technically can go in there, but then it can't turn around. It would have to reverse, and then it can turn around in the bigger area. So the other thing to mention is the IMU that's right here. We'll be using that to estimate the displacement as it moves. So when the Raspberry Pi like does the scanning and it determines like this distance is clear and it says go forward, you know, say 10 inches, this IMU has to verify that. And that's you have acceleration values, you add them up over time. It's very crude. We're not doing like actual integration, but yeah, so well, we'll get the velocity from acceleration, then we multiply time in order to determine the distance it moved, this right here. So yeah, we'll do this panning. It'll, when it starts off, you drop it off somewhere, it'll do these pans. Let me go back to black here. It'll do these pans. It'll rotate, based on this size. So the next one will be like there. Robot's facing that way. Goes this way. Robot is now facing this way. It'll just do that until it comes back to, this area here. There's probably going to be like overlap, but yeah, that's the plan. Alright, so what I'm going to do is take a couple of flat floor scans. So I've got this black mat thing, and I've got my brown carpet, which is what everything is mostly covered with. And I also have the wooden floor, so I'll just get those 3 scans and average them. That'll be the baseline. Then what I'm going to do after that is I'm going to determine the angle that will be the scan amount, and then I'll be able to determine what angle it turns to do the other scan, and then it'll just do a full circle. This is assuming it turns on a dime, which I want to say it does, but it's possible it doesn't. Anyway, once we have that, then we'll know like an area around us is clear and how big, and then we can move forward a certain amount and repeat like half of it, because we've done like a circle. And that'll just slowly build a map over time of areas that are explored. And then it should be able to tell like where things are in reality. And then you can be like, alright, go over here, and it won't even have to scan anymore. It'll just plot a course through the known open space. That's how you know you've actually built like a mapping robot. But yeah, so let's get to it. So I just want to highlight the caliber of a programmer that I am. So I did 6 samples, right? Black mat, so pretty much twice of each one. And then what I'm trying to do is figure out like the average, and the this right here. So I mentioned I really like JavaScript, right? The programming language. Like, people hate on it, but it's great as far as just being able to do whatever. And for example, like this, where you're trying to work with data. So what I was trying to do was combine the sample points and group them. I'm not saying only JavaScript can do this, but yeah, it's easier for me to use JavaScript. But anyway, the point is, like, so this one right here, 955, 924, 91793, I wanted to combine those together and then see how far apart they are. And unfortunately, it took me a while to do that. It seems simple, right? It took me like, I don't know, an hour. Trying to like rebuild the structure, you'd think it's simple, just use the active keys. But my point is, I got past all that and I got what I wanted. And then what I want to do is get it into a spreadsheet, which tables use, like the table tag and HTML tag, and then you use table row, table data, or if that's what those mean, and the values inside. So then you produce that and you see the output here. This is HTML. Then you can copy this into a spreadsheet, which I had to dump it into a notepad first, like copy paste, copy this, and then put it here. But so now the data is grouped as I wanted, like 955, 924, 917, 955, 924, 917. So like that is a data point. I can plot these. Let's see, what do I do? Insert chart, and then I have to specify like the axes. Oh, it's on the right side here. The X is supposed to be like this, the iteration. budget, not sure. C, no, this is not right. I want B2. Oh, wait, what did it say? Maybe it is right. C2 to C26. The series, the data. C2, it says D2. Damn, hold on. What I gotta do is this. Well, actually, I can just drag it, but whatever. Insert chart. And I didn't want this kind of chart. I wanted like a dot. It's like a scatter plot is what I want. Yeah. Yeah, so this is your set of errors, which oh, and I did want to point out, I corrected the data because like here, this number like 319, that means infinity. Like the sensor did not get a response back, which is possible if you're like scanning something reflective like a floor, and it's like at such a shallow angle that it doesn't get enough reflection to register. It's as if you scan the void. So yeah, like these look good. What's problematic is this. I don't know. 3615, what is that? Oh, those are the ones I corrected. Yeah. Actually, let's see. Blue is my chart. Yay. Excel certified. Oh. This doesn't matter. I don't really care. Anyway, the point is, yeah. So you see, like, for the most part, the data is consistent. There is a, you know, an average error, and I'll factor that in. I'll in Python like loop over these data points again and then average them, so then I know what's like a janky sensor value versus like something is there. So yeah, I'm gonna go to figuring out the angle and then how much it has to rotate, how many times to do a circle. Unfortunately, I'll have to work today in like an hour or so. I may not get far on that. But I have all day tomorrow, Sunday. I'm tired. I gotta go drive Uber Eats, man. 10 hours straight. Fun. I have a day job too, like 40 hours, but trying to grind that debt payoff, man. Anyway, yeah. So that's helpful to visualize and make sense of data. There's something I'm gonna fix. You can see if you look at the wheels head on, they bow outwards. And that's because these servos, when they're mounted, they pull outwards like that. I'm gonna glue the things down. I was gonna design and 3D print something, but I don't want to take the time. I gotta work on the code stuff more. So I'm just gonna hot glue the servos more, so hopefully they don't bend out as much. As you can see, like, yeah, that gap right there is why they're bending outwards. So this is our like 3D model of this robot. It's the height, width, length values, and then this is the sensor height off the ground in the neutral setting where it's like looking straight ahead. And then this right here is the rotation point. So I transferred that over here, and the box is like that. And then I rotate it about that point to get the maximum, you know, space it takes up if it spins in a circle. So that's what this circle is. And the rotations are based around the center of the wheels. It doesn't even get to factor in like the IMUs over here, so it's not rotating about this point. So the displacement, like when it's measuring stuff, that'll have to get pulled backwards by this distance. Which I can find that out real quick. Man, I'm so hungry. Let's see, let's just, what is that, 15? Yeah. So, the very center of this IMU, measure backwards to this point right here. 2.78 inches. Alright. I'll write that down. So I just said 2.78. Dude, my short-term memory is so bad. Alright. 2.78, yeah. Okay. I think it's Y. No, Z. Okay, yep, so let me get to it. I'm gonna program this in so I can do the scan, and then we'll test with objects the difference in measurements. Alright, I apologize for that. I'm not using the other mic. I just want to show something. Like, I was trying to calibrate it to do like left and right 90-degree turns, and it's annoying they keep having to program this thing, so I'm just going to make it where the WebSocket can program this, or tell the servos how far and how fast to move versus me having to program them in. But anyway, the point is, if you watch, it turns faster right than left, even though the degrees are the same, so that's the annoying thing I have to fix. So I'm just remotely controlling it right now. I'm going to make it go right. It's supposed to move the same amount, like right and then left, so to end up in the same position. So right, like, that looks good, that's fast. I go left. Like, why? Why is it like that? Alright, so production value is really dropping here, but you can see this is the new command, right? Raw command, 85 degrees, 85 degrees, 800 milliseconds. And then if you watch, it's plugged in. I click that button and it'll turn, yeah. So this way I'll be able to just dial this in without reprogramming the Arduino every time. That's pretty good. Call like 890. Okay, so here's 11.5 inches dialed in. What the hell just happened with the wheel? It's pretty solid here. I'll do it again, but this time I'll keep this. Try to make sure like it stays parallel with that edge. Yeah, that's really good. I mean, once it knows a path, yeah, you can draw straight lines that are massive, but I do have to figure out the corrective thing. I'm not sure if that's a PID situation, but, or it's like if it's trying to go straight, reduce the yaw exerted on the IMU. Let's just see if I can use that same code, but make it like longer time. Oh, damn, that was a lucky guess. Look at that. What is that? 2,500 milliseconds. Okay, so unfortunately I am pretty mentally drained. I started working on this like 8 hours ago, but it's sad because it's like I didn't get far. One of the reasons is like trying out the narrow sensor was a waste of time. But I'm also just drained in general. Like I work 6 days a week, and this is the one day I gotta get this stuff done. Sorry, I'm complaining, but anyway, let's yeah, damn. I wish I didn't feel so like mentally burned. Okay, I'm just gonna explain what I did. So in the previous video, you saw it like doing a full floor scan, turning 90 degrees, doing it again. So it did it 4 times to do a full circle. What I was trying to get done today is the plotting part, where in ThreeJS it's pretty straightforward to plot a plane. You specify the 4 points. These are three-dimensional vertices. Is it vertices or vertex? I remember like one of them is the intersection of lines, but the point is, oh my god, I'm drawing with a mouse. It's supposed to look like that, right? That's XYZ. So you specify that and you give it an X value, you can color it in. So that's what will happen here. The thing to consider is the robot starts off, you import it with the IMU at the center. That's not a good color. There. So if you were to plot this thing here, oh no, I shouldn't do that. Come on, hold on. If you were to plot this thing here, you have to like offset it. You could either like split it in half and like mirror it, but actually, hold on. What we're plotting is these 3 sections, which, let me pull up the SketchUp. Yeah, so back to this thing. These values are the shortest, or yeah, distance, like left or right. So it's like, and also you see like this red line is the horizontal. This one's angled slightly upwards, so I went with this one. That was the whole point of this. It's like closest and narrowest, like to the axes. So this, if you had a full floor scan, this is the area you would expect is clear, and it would be a little bigger actually because, you know, the center of the beam is like a ellipse. So like technically, it covered, you know, a whole area. You could even say like it's like this, or I don't know. Anyway, like this whole thing is crude, but yeah. So that's what that is, and you have to plot it, which, with regard to the whole, you know, mirroring thing, how do you do that? And I think you could just take this rectangle here, like A, and when you want to plot right in front of you, you shift it left and forward, and then it's still like a rectangle you plot. But and then with the IMU, you if you say go forward 10 inches, which right now that's assumed, there's no feedback yet with the IMU, but that will be added because I noticed like even if I dial in the servos, it still like slips somehow. So it's like the 45 degrees is not perfect. But yeah, so we'll start building a map from the scans, and so if it scans this, it'll move forward and scan again, and you know, that'll be clear. And yeah, that's the whole point of the robot, is just it'll keep exploring and building up this map and plotting obstacles. That's another thing I'm still working on figuring out. So it's like if it's scanned over here and then it hits something right there, you know, how big should that be for me to assume like I can go around it? Which a simple way to think about, or that I was thinking about, is if there's something here, then abandon this whole depth. It includes these ones too, so you would turn and go somewhere else. And that's where like the vision part comes in, because the vision can check what, you know, it probed. But anyway, let's talk about the code real quick. So what is this? Yeah, the code right now is arranged, you know, by context purpose. Like the web client is just like an interface you can look at. That's this thing here, for example, web interface. I actually use the ESP one to dial in the dimensions and for the servos. So on the vehicle side, the ESP code is the same. Arduino is the same. What I changed is motion. I got rid of all the hard-coded commands like move right, turn right, and I just went for a command like this where it's fed in dynamically. That way the Raspberry Pi can just tell, or the web interface can tell this robot what to do without having to like program it again through Arduino. So I did that. I explained how it works. It's like you put in degrees, left servo, right servo. This is milliseconds, and then that gets pulled down here. And yeah, so there's that. Raspberry Pi, go in here. You can see I brought in the narrow angle to navigation, but actually I'll probably take that out because it's not used there. There's the vehicle socket. That's another change. It's like socket server versus socket client. So socket server, the Raspberry Pi runs its own socket, you know, a server, which is what the web interface connects to, and then the Raspberry Pi connects to the ESP socket, which is how it steers itself, like the car. Motion is the servos of the Raspberry Pi, like the pan tilt. Yeah, vehicle socket. I think I'll call this like wheels or something at some point. But yeah, and if we look at navigation, the code to do the 360 scan is a basic for loop, like, you know, scan the floor, turn right 90 degrees, scan again, and it's being stored. This isn't for any particular reason, but I'm just storing it in a way that's like ascending with time. So it's a dictionary object, a timestamp like epoch. That's the seconds from 1970 or whatever. That's what's being used as the key, and the values are stored in there. But yeah, so did I do anything else? I don't know. So yeah, and then when you see this run right here, instantiates everything, so they're good to go, and then you boot, run the full floor scan. As far as the socket client thing, I tried to make this where it just persisted, but right now it seems more stable to just connect every time you want to send a command, so that's what it's doing. This is the ESP01's socket, web socket that it hosts. So yeah, when you want to make it, where are we at? When you want to control it, you know, like this, when you send this, it's going through here, like the send message, and the ESP01 receives that and feeds it to motion, and then raw command is parsed and it controls the servos. So yeah, the part I didn't get to today is the actual like math to figure out. We got all these min, max, average values. If they change, it must have hit something. So we can only go so far forward or not at all and turn around and then start building the map in ThreeJS. Well, it's not in ThreeJS, we're building it like in the Raspberry Pi. So it has like a map of the world. And then it's also relayed to ThreeJS so the human can see it. Over here, like eventually we will have like a camera feed and whatnot, because I'll see about the live stream. Like, that's possible. I was just thinking about, is it like a waste of compute resources? You know, it's supposed to be like autonomous. What I was thinking is like if it had a problem where it's like it runs into something, it could, you know, send an alert to the user and be like, all right, I ran into this thing, and there's a picture from the camera. But yeah, there's still a lot of like data processing stuff. I just worked on making it all bridged. I wish I got farther, but yeah, I'm kind of spent. I gotta do like nothing before my week starts again. I'll chip over the math stuff over the week before next Sunday. Yeah. Oh, and this is the narrow angle stuff I plotted. It was just so bad. It's like, it's supposed to measure like 20 degrees. I mentioned this in another video, or clip in this video. I was expecting 26 degrees, but it said 40. Like, what? So, yeah, it was just bad. That's why I'm not using it. I had to remeasure this sensor's position and all the turns and whatever. So, yeah, that sent me back some time. It's just weird. I mean, I still plan on using it for, like, the camera when it's masking something. Trying to position that in 3D. But, yeah.